Hello, a pleasant good morning to our viewers. Welcome to our anatomy and physiology segment. In today's segment, we will be discussing the hemolymphopoietic system 3. My group members are Rashida Beckford, Shanae Anson, Tracy Ann Simpson Wilson, Leonard Ebanks, and yours truly, Sanisha Holness. So, what is the hemolymphopoietic system? This system is also known as the lymphatic system. It is a network of organs and tissues known to be necessary for the body's fluid balance, blood cell production, and immunological system function. Now, among the vital components of the hemolymphopoietic system that support maintaining health are the spleen, the thymus gland, and the lymph nodes. The lymphatic system is made up of the spleen, the thymus gland, the lymph nodes, lymphatic veins, and other lymphoid tissues. The system is vital for immunological responses, fluid homeostasis, and nutrition transport. Now, in this segment, we will be diving into the anatomical location, the gross anatomy, the microscopic structure, and the general functions of the spleen, the thymus gland, and the lymph nodes.
Good day. I'm here to talk about the anatomical location of the spleen. The spleen is a small organ that rests on the inside of the left rib cage, just above the stomach. It's a part of the lymphatic system associated with the immune system. It is found at the left hypochondriac region above the upper part of the abdomen, left upper quadrant. It is located more posterior to the stomach and has an inferior location to the hemidiaphragm, inequality to the ribs. Midline the spleen is the left kidney. Diaphragm is position superior means while inferior lies on the left colic flexor, splenix flexor. The size and weight of the spleen can vary from person to person. It's about 2.5 thick, 7.5 centimeter broad, and 12 centimeter in length. That's the variation on the size of the spleen. The growth of the spleen is a dark, vascular, soft organ with superior and inferior poles. It also has three borders: superior, inferior, and intermediate, and two surfaces, diaphragm and visceral, covered by the visceral peritoneum. It has a capsule of dense irregular fibroelastic tissues collected by myofibroblasts. Trabeculae extended from the capsule into the parenchyma, dividing it partially. Its stomata consists of reticular connective tissues supporting lymphocytes, macrophages, dendritic cells, and blood cells. The gross anatomy of the spleen is considered to be the areas in which the functioning of the spleen begins.
The microscopic structure of the spleen. According to KEDHUB 2023, the spleen has numerous spectra known as the trabeculae, which stretches from the capsule's dense irregular fiber elastic connective tissue into the splenic parenchyma called the pulp. The pulp has two main parts, the white pulp and the red pulp. The white pulp. The white pulp of the spleen is made of three different compartments. The para-arterial lymphoid sheaths, known as pulse, the lymphoid follicles, and the marginalized zone. The pulse consists of central artery and the lymphoid tissue. The lymphoid tissue is organized into two layers, the T zone, which primarily has T lymphocytes, and an outer layer which has a diverse mix of T and B lymphocytes. There are primary fascicles and secondary nodes, which depends on the B lymphocytes features. The white pulp also has a germinal center where lymphocytes mature and produce antibodies. The red pulp. The red pulp of the spleen comprises primarily of the stromal tissue, which includes the cords of Billroth and the splenic sinusoids. The cords of Billroth are cellular aggregations supported by reticular connective tissue. The sinuses are situated amidst the cords of Billroth contribute to the red pulp's color due to their blood-filled nature. The microscopic structure of the spleen. The blood vessels. Blood enters the heart. Blood from the heart enters the spleen via the splenic artery through the ileum. It exits through the splenic vein into the peroneal vein. The splenic artery branches into smaller arteries, which forms arterial capillaries, which are surrounded by macrophages. The blood then flows through the venous sinuses in the red pulp because of the elongated endothelial cells, which do not have any junctions. It allows for wide gaps between the cells so the blood can pass through. The functions of the spleen. The spleen has an immune function, a blood filtration, blood storage, hematopoiesis, immunological response, and red blood cell cycling. The, the spleen produces lymphocytes, it creates and removes red blood cells, it stores and clears pallets, and it filters pathogens, it recycles iron, and it synthesizes antibodies.
Good day. My name is Rashida Beckford, and I'll be presenting on the anatomical location and the gross anatomy of the thymus gland. The anatomical location of the thymus gland. The thymus gland is located in the anterior mediastinum of the thoracic cavity, behind the sternum, also known as the breastbone, and in front of the great vessels such as the aorta. It lies superior to the heart and extends into the lower part of the neck. Anteriorly, thymus is located behind the sternum, forming part of the anterior mediastinum. Posteriorly, it is related to the pericardium and the great vessels of the heart. Superiorly, the thymus extends into the lower part of the neck, reaching the level of the thyroid gland. Inferiorly, it may extend to the level of the fourth costal cartilage. And on the right hand side of the screen, you see a visual representation of where the thymus gland is located. The gross anatomy of the thymus gland. The thymus has a bilobe structure, with each lobe having a pyramidal shape. It has a pinkish gray color and a soft glandular consistency. The lobes are further divided into lobules, and each lobule contains a cortex and a medulla. The size of the thymus varies throughout life. It is relatively large in infants and children, reaching its maximum size during puberty. With age, the thymus involutes or decreases in size, and the tissue is gradually replaced by adipose tissue or fatty tissue. The thymus is connected to the surrounding structures by connective tissue. Blood vessels, including branches of the internal thoracic artery and veins, supply the thymus with oxygen and nutrients. And the outer cortex and inner medulla is also included in the gross anatomy.
I will now be continuing with the microscopic structure of the thymus gland. Now, the thymus is separated into medullary, cortical, and subcapsular zones within each lobule. Now, these divisions are formed by connective tissue septa that extends from the capsule. Now here in this image that we have here on screen, you can see the lobules clearly identified, with the cortex being identified as the peripheral, rather, the darker peripheral of the lobule, while the medulla is the central and lighter part of the lobule. Now, the color variation that can be noted in the cortex and medulla is caused by the thymocyte density in each respective area. It can be said that the thymocyte density is more in the cortex and less in the medulla. Now, within the thymus, there are two major categories of cells. These cells are thymocytes and thymus epithelial cells. There are also reticular cells and various lymphocytes, including T, B, and natural killer cells. These form the main cellular composition of the thymus. Moving on to the functions of the thymus gland. Now, the primary function of the thymus is the development and maturation of T lymphocytes, also known as T cells. Now, within the thymus, multiple steps of differentiation and proliferation result in the production of T cells. Thymocytes, which originate from the bone marrow, migrate to the thymus. Now, in the thymus, they undergo several phases of maturation. They transition from the subcapsular zone through the cortex and medulla and ultimately emerge as mature peripheral T cells. Now, in the intrathymic rather migration, during this process, thymocytes they proliferate and differentiate, and they emerge with altered cell sizes, and they begin to express interleukin receptors and differentiation antigens. Now, T cells that are produced by the thymus, these are involved in fighting infections, and they fight against several foreign bodies, including antigens and pathogens.
Good afternoon. My name is Leonard Banks, and today I will be talking about the lymph nodes. What are lymph nodes? Lymph nodes, also known as lymph glands, are parts of the immune system. They are small lumps of tissue that contain white blood cells. The function of a lymph node is to filter out harmful substance and waste products. It also destroys bacteria and cancer cells. As shown in my background, lymph nodes are bean-like in structure. They are about 0.1 to 2.5 centimeters in length. The mode the node is enclosed in and has a indentation known as the helium, which is where veins exit the node and arteries bring in nutrients. When cut horizontally, the dense connective tissue capsule, which is made of fibroblasts, collagen, and elastin, projects trabeculae inside, giving the node a lumbar appearance and housing its main blood arteries. This can be seen in the diagram behind me. There are approximately 800 lymph nodes in the adult body. Lymph nodes are found in convergent blood vessels. They can be commonly sighted in the neck, axle, thorax, abdomen, and groin. Look at the diagram behind me, which indicates some of the locations of the lymph node in the human body. This is the end of my presentation on the lymph node.
We are now at the end of our anatomy and physiology segment. Thank you for watching and have a pleasant day.